Good morning, students. Today we are going to discuss bit fields and file management. I am here from Silveroak Engineering College and Technology, and today we are going to discuss some of the introduction of union as well as bit fields and file management. So let us start the introduction of union. Union is kind of similar to structure, as we have discussed last time. Union is a special data type available in C to you, which stores different kind of data types, right? So if it is integer, if it is float, if it is string or characters, we can combine them, club them together into a single title, right? So that is a structure. Now what is the difference between union and structure is, in union you cannot have the sizes for individual data types. The largest one will occupy the size of union, right? So union is a special data type available in C that enables you to store the different data types in the same memory allocation. You can define a union with many members, means a union can have members together with it. Suppose you are saying a student named union, right? So that particular union will store students' ID, students' name, students' age, right? So they can be having memory allocated to them, but the difference is that the largest one will only have the memory. Union provide an efficient way of using the same location for multiple purposes. Means what? The memory which is allocated, that will occupied by the largest one. So until the largest one comes, each can be stored, but when that particular value comes which is holding the largest memory allocation, then this all particular members will be lost. So how to define the union? Again we need to use the keyword union to define the union. So you must use the union statement in very similar we did with the structure. So structure mein how you used with keyword struct, here we need to use the keyword union, right? This is the example of the union syntax. So let us take, we are writing union, so union is the keyword, then we are writing name of the union, that is the union tag, then we are writing the braces that defines the scope of union, and then we are writing member definitions. Member definitions means, suppose I want to have two integers, two floats, so they are the members of this particular union, so we are declaring them, and then we are closing the union's scope. Then whatever numbers of variables we want to declare for this particular union, that we are writing one or more by comma separated. If it is one only, we are writing that name and then semicolon. If they are multiple, we will write comma separated list of union variables. Let us take an example. The name of union is data, the keyword union, so we are writing union data. In that we are having three members, integer I, float f, and character str 20. This character str is a string of 20 characters, and I am declaring one particular variable of this particular union, and that is d1. Some points to be remembered with union is, as I said earlier, the memory occupied by a union will be large enough to hold the largest member of the union. Means what? The memory, total memory of a union will be of what size? The largest member of that particular union. Suppose you are having one integer and one float, then out of that the structure's memory is 2 plus 4, that is 6 byte. But if you are considering union, then it's 2 plus 4, that's 6, that is not applicable. We are having only 4 bytes, that is for float. So example is there. In the above example of data, as we have seen here, integer will occupy 2 bytes, float will occupy 4 bytes, and the character string will occupy 20 bytes. Instead of 2 plus 4 plus 20 means 26, we will be having only 20 bytes, and that will be of character string. So that is written here in the above example. Data will occupy 20 bytes of memory space because this is the maximum space which can be occupied by the character string. So let us say, if you want to see the size of that particular member, then we will see memory size occupied by the data, %d size of data. Size of is the operator which returns size of particular element which is passed in the brackets. So we are passing data. What is data? Data is the variable of union data, right? So we are getting the answer 20 here. And what that 20 is? The 20 is the largest element of data union. So the size over here is 2, 4 and 20. So the largest 20 will be allocated as the size of any member of this union. So we are creating data as one member of this particular data union. So the size of this particular data will be 20 bytes. How can we access the members of union? That is the same as structure. Suppose we want to access the member of structure, we are writing period, right? So we are having something dot something. The same way we are getting the unions access, right? So suppose there are three items, integer I, float f and character string 20. So here again, if you want to access I, f or this particular str element, we need to write data dot I is equals to 10, data dot f is equals to whatever value you want to give, and data dot string if you want to give any value to string. But as you know, if you want to assign any value to string, you cannot directly write, so you are better giving string copy function. String copy is the function from string.h file. So you are writing string copy, this is the destination and this is the source, so this will be copied to data dot string. So this particular data element will be having 3 elements inside it, right? They are the, as you can see, data. So you will be having 20 continuous bytes for them, right? So suppose first you are storing what element? 10. So that 10 will be stored amongst 2 bytes, right? Because that is the integer and that will occupy 2 bytes. So when you are printing that data, you will be having answer 10 for that. Again, if you are giving data.f is equals to 220.5, it will occupy further 4 bytes for that particular float value, right? Now what you are doing? You are copying string, data.string C programming. So what it will do? It will lose these all values, and instead of all this value, all the 20 bytes will be occupied for string. So here the string will be stored, and that is C programming, right? So the answers are like this: data.I is 10, data.f is 220.50 and data.string is C programming. They are not the values which are printed simultaneously, right? You are printing one by one, that's why you are getting the output. If you are doing like this, that you are giving the value, you are giving the value, you are giving the value, and then you are printing them, then what happens? These occupied results, as I showed here, these 2 bytes, these 4 bytes, they can be accommodated together, but when the string will come, these values will be lost, these values will be lost, and the whole 20 bytes will be occupied for string purpose, right? So the output will be corrupted output for I, f, and the string will be stored as it is. So as I said, values of I and f will get corrupted, but string member will be printed very well, right? So that's all about the union. The only difference between union and structure was the memory allocation. Others, everything is same. The keywords used are different. The keyword for structure is struct and the keyword used for union is union, right? So that's the only difference. Now let us move to one more point, that is bit fields. What is bit field? Let us take an example to understand this thing. Suppose I have a structure and the name of that is student. The name of structure is student. We are having 4 variables. They are having integer data type. What they are storing? They are storing the values in yes or no, whether that particular person is pass in maths, pass in physics, pass in CPU and pass in EME subject. If they are pass, we are storing 1. If they are fail, we are storing 0, right? So what is the memory that is required for this thing is 1 bit, right? The pass in maths, we are storing 1 if it is passed, so we are storing 1. If the person is fail in physics, we are storing 0. If the person is fail in CPU, we are storing 0. If the person is fail in EME, we are again storing 0. And character name of 10. That is a string variable which is storing 10 bytes, right? 1 byte for an individual character. So that is an array of 10. So we are storing 10 byte for this particular name. So we are printing size of this particular variable of student structure, and that is S1. So I am printing size of S1. Again, as I said, size of returns the value in byte, that particular amount which is stored in a memory by this particular element, that is S1. So S1 is a member of student, so it will be occupying 2 byte, 2 byte, 2 byte, 2 byte. So 2 plus 2 plus 2 plus 2, that is 8 byte plus 10 byte for this particular string. So total it is storing 18 bytes, right? So that is the result. Size of structure is 18. But as we all know, if you are considering 8 bytes, you can have 2 raised to 8 elements to be stored, right? So the elements size is 0 to 65536, barabar? 0 to 65535. But here we want 0 and 1 only, barabar? So what happens? The memory is getting wasted, right? So what is the option? The solution is C programming language offers a better way to utilize the memory space in such situations. This is a situation where the memory is getting lost. So what we are doing is, we are having a way to specify the memory in number of bits wherever we require. So you can tell the compiler that this particular variable is needing this particular bits only, right? So for that we are using bit fields in C. How you can use the bit field? So let us see that example which we have seen before. This example can be rewritten like this also. We know that pass in maths, we are specifying the bit size is 2. See the concept here. We are having 1 bit size for variable that is pass in maths, right? 1 bit size means what? Whenever we are saying that this particular element is storing 1 bit, we are occupying 1 bit in the memory. This 1 bit can store only 2 values, that is 1 or 0. So there are 2 alternatives, and that is 2 raised to 1. 2 raised to 1 is the size of this particular bit area which can accommodate 2 values, that is 2 raised to 1. The 1 is 0 and the other one can be 1. Right? So here we just need that this particular person is pass in maths or not. So we are either specifying 1 or 0, right? So the syntax for writing that is integer pass in maths, then we are specifying 1 as the size, right? Then physics 1, CPU 1, EME 1. So what we are giving is that individual was storing 2 bytes initially. So that was storing almost 16 bits for that one element, that is pass in maths. But here what we are specifying, we are giving that this particular element will store now only 1 bit. So we are saving 15 bit for individual variable, right? So for that such 4 variables we are saving 60 bits. If your data is quite longer and if you are having such variables like 20 variables of this kind, you can save quite more memory. Okay, so let us see here this 1 bit, 1 bit, 1 bit. So total they are having 4 bits plus 10 byte of this. So 10 byte plus 4 bits. 4 bits will be considered as 1 byte. So whenever you will retrieve the size of this particular element, you will be having 11 bytes only rather than having 18 bytes. So this is the use of bit field. You can specify the size of that particular variable in number of bits by colon. Right. So after colon you need to specify that. Let us see this syntax. In this structure you can use the bit field. So you are writing type, which type of data is that, then you are specifying name of that particular variable, and then you are specifying the width that will be occupied by this particular variable. So that is the information. Byte is the integer or signed integer or unsigned integer, whatever you want to consider. Then member name, that is the name of member variable, and then width means number of bits you want to occupy by the bit field. The points to be remembered is width must be less than or equal to the bit width of the specified type. Means suppose you are considering integer then you are considering suppose pass in maths. So integer is occupying 2 bytes, right? So that is 16 bit. Then you cannot specify colon 18, because if that particular variable of integer data type is storing 16 bits, you cannot have larger value of width for that particular thing. So bit field is always less than bit field's value is always less than the bit width specified by that particular type. So type is integer, then you can at max go to 16, not larger than 16. If it is a float, you cannot have larger value than 32, right? The variables defined with a predefined width are called bit fields. Whoever variables, see here, suppose you are considering these 4 variables, they are specified with the width of bits, so they are known as bit fields. This cannot be known as bit field because it's having its regular size. Here you are contracting some size, that's why you can say that these 4 variables are bit fields. Okay, so what you can do is bit fields variable can store only those data which is into the size of specified bit field. Means, as I said earlier, if you are considering pass in maths variable, right, you are specifying only one box, that is 1 bit. Now what you can store in this is either 1 or 0. You cannot specify 2. Right, suppose you are giving the value of this particular variable, you cannot write pass in maths is equals to 4. You cannot specify that. Why? Because what value you are giving is in the 1 bit. So 4 cannot be accommodated in 1 bit. That's why that is the limitation. If you are using bit field, it can only have those values which can be accommodated. It can be hold, right? If you are giving 3 bit size, it can go up to 2 raised to 3. It's starting with 0, so you can go up to 0 to 7 only, right? Let us see one example. Suppose you want to give student's age, right? The student's age cannot be have larger than 120. Say for example, you can go for suppose you are considering in the terms of 2's power, then at max you will be having 100 as a size of student, as the age of student, right? So a student's age, suppose you are considering is 100 or 101, at max suppose we are considering the student's age limit is 128.